Okay, now we're going to think about using our understanding of the nth term to apply it to what I've called nth term shape problems. And I'm sure you've seen sort of similar things to this in exam questions. So what we're told then is that we've got a sequence here of shapes and they're all made up of matchsticks. Okay, a typical question would be draw the next shape. Well, you can see that, can't you? We're simply adding two squares as we're going along. So I'm not going to take time to draw that. I'm sure you can see that that will be a relatively straightforward question to ask. Where it gets a bit trickier though is this type of question. How many matchsticks in the nth diagram? Now the language, you think, I'm not sure what that's about. All it means is, what is the nth term of this sequence? Okay, now we've got a bit of a challenge at the moment because it's not a linear sequence, it's a sequence of shapes. So what we've got to do is bring our understanding of the nth term. Let's call that term 1, that's called term 2 and term 3 and so on. But this time let's think how many matchsticks makes each shape. Well, we know that that's 4. When we count those up we get to 10. When we get there we get to 16. Now, once we're into linear sequences like this, we can use our understanding of finding the nth term. Remember, with our 3 circles, the first one is a term to term difference, which we see as 6. And the last one, well, we haven't yet sorted out this, is our term 0. If the term to term difference is 6, term 0 would be -2. That would slot in there, which tells us that the nth term of this diagram in fact is 6n minus 2. Okay, right. Now, using that information then, the next question might say, well, the question might say, how many matchsticks are there in the 25th diagram or shape? Well, we know that that's what we also mean is that's the 25th term, don't we? So using our information here, we can simply substitute the term value for n. So 6 lots of 25 is 150, take away 2. So in the 25th shape, well, we'd need 148 matchsticks to make that shape. Okay, and then the final question, the final type of question that we've got here, so let's remember 6n minus 2. Let's just keep that there in the back of our minds at the moment. The type of question that we would be facing is, if I had 200 matchsticks, what's the largest number, or the largest number of diagrams, or the largest term that I could create? The largest term that I could make. What would that be if I had 200 matchsticks? Well, this is where we use our understanding of the inverse operation and setting up equations, because what we're really doing is testing 6n minus 2 equals 200. And then 6n equals 202, because we've changed the side and changed the sign. N is 202 divided by 6, which equals 33, remainder 4. So the largest number of terms or shapes that we could make would be the 33rd term, but we'd have 4 matchsticks left over. And that's it.